Let's look at our first example. Let's solve this first equation by completing the square. First of all, I want to eliminate that minus 5. So what I'm going to do is add 5 to both sides of my equation. On the left side, that cancels. On the right side, I'd have 5. And what I want to do at some point is figure out what number needs to be added to both sides of the equation. That number is what is necessary in order to complete the square of this trinomial. Now here's what I mean by complete the square. First of all, let's go ahead and just factor it as we normally would. First of all, you'll notice that the coefficient here was a 1. That must be the case in order for this method to work, or at least for this method to work easily. Because what I always want to have here is x times x gives me my x squared. Now normally when we're factoring, I would look at the last number, but that last number does not exist. What I do know is it will always be a positive, and I must either have a positive times a positive or a negative times a negative. In this case, since my middle term is a positive, this will be a positive times a positive. I also know that my inside and my outside terms must total up to be 6x. Basically, since this coefficient is 1, I will always split this number in half. So my 3x and my 3x gives me a total of 6x. Now again, if we work backwards here, x times x was my x squared, my outside and inside combined to be my 6x. My last times my last gives me the last term of that trinomial. What I really needed up there was a plus 9. Well, I can't just go back and add a plus 9 because I feel like it. If I add 9 to the left side, I must add 9 to the right side. Which of course means down here I would add 9 to the side as well. Rewriting this left side, I now have my perfect square. I have one binomial times itself, which yields this trinomial. This trinomial, therefore, is a perfect square. It is the square of this binomial. At any rate, I now have x plus 3, that binomial squared, equals 14. Now what I'll need to do is take the square root of both sides of my equation. On the left side, the square and the square roots simply cancel, and I have x plus 3. On the right side, I can't take the square root of 14, so I'm just going to leave it as the square root of 14. But remember, this could be either negative or positive, because a negative number squared would also yield 14. So I will list this as either positive or negative, the square root of 14. And for my last step, I merely need to subtract 3 from both sides of the equation. Over here on the left it cancels. On the right I'll put it in a more proper order. I prefer the whole number to come first and the radical last, and this yields my final answer of negative 3 plus or minus the square root of 14. Let's take a look at our second example. In this case, once again, it won't factor. So once again I'm going to complete the square, and the first thing I need to do is eliminate this 5. Again, I'm going to replace it with a number that will create a perfect square, some binomial times itself that would result in this trinomial. Now the problem is, I don't know what number needs to be here for this to be a perfect square trinomial. I'm going to leave it blank for right now. I'll put a plus sign there because I do know that if I square either a positive or a negative, I will get a positive. Now, let's take a look and try to factor. I know that x times x, again, will give me my x squared. I know that both terms will be positive because I need a positive middle term. This problem is slightly different than the last, though, in that it looks like I can't really take half of 3x. At least I can't do it as easily as I took half of 6x in the last example. You can, of course, still do it. You could literally put 1.5 or 1.5 in both places, but to be honest, the arithmetic will be easier if you just allow this to stay in fraction form and put 3 over 2. Now basically, that's the improper fraction form of 1.5. I literally took my 3 and divided it in half, or divided it by 2. Now, if I have my x times my x is my x squared, my 1.5x and another 1.5x is a total of 3x, that now tells me what term I needed to have here to complete my square. My 3 halves times 3 halves would be 9/4. Of course, I can't just put the 9/4 there. If I put it on the left, I have to add it to the right. And of course, if it's in this step, copying down it would naturally be in this step as well. Now let's do a little of the arithmetic. First of all, x plus 3 times x plus 3 is simply x plus 3 squared. Now let's look a little more closely at our 5 plus 9/4. To add these two together, I'm going to need to make this 5 into a fraction, so I'll simply put it over 1. And now I have 5/1 plus 9/4. I need a common denominator. Since this is a 1, I can multiply it by any denominator I need, in this case a 4. That will give me 20/4, plus 9/4 gives me a total of 29/4. So basically, I have the quantity x plus 3 squared equals 29/4. Once again, I merely take the square root of both sides to eliminate my power. And I have x plus 3 equals either the positive square root or the negative square root, because remember again that a negative number squared could also equal positive 29/4. Now, I can't evenly take the square root of 29, so I will merely indicate it's either positive or negative, the square root of 29. And the square root of 4, however, I can do. That's 2. At this point, I now have x plus 3 halves equals positive or negative radical 29/2. I will again merely eliminate the 3/2 from both sides to get x to be by itself. I will put this in the proper order and I will combine it into one fraction, leaving me x equals -3 plus or minus the square root of 29, the entire quantity over 2. Let's take a look now at our third and final example. This one's different for 2 reasons. One of the reasons is my first coefficient of my x squared term is not a 1. So the first thing I need to do is divide through my equation by 2. I must literally divide both sides of my equation by 2. Now on the right side, of course, 0 divided by 2 is 0. On the left side, I'm going to distribute this 2. I can literally think of this like it's 2x squared over 2, the 3x over 2, or the -5/2. Or if you prefer, it's more or less like distributing 1/2 through the parentheses. In any case, on my first term, the 2's will cancel, and I'm left with just x squared. My second term, I'm going to leave 3/2, or 1.5 if you prefer, minus 5 halves. Now at this point, once again, this number, this constant on the right side, is the one that's preventing me from completing the square. What I'm going to do is I'm going to add 5 halves to both sides of my equation. Now, on the left, that leaves me with my first 2 terms, and on the right, I have my 5 halves. What I now need to determine is this last term right here. I need to determine what number needs to go there in order to complete the square. Again, the only thing I know about that number is it needs to be positive. Whatever that number is, I will also have to add to the right side. Let's look at factoring. Once again, I have x times x is my x squared. I need my outside and my inside to total to be 3 halves. Now what I'm going to do as always is literally put half of that in both of these locations. So I think of that as half of 3 halves, or 3/4. I'll put a 3/4 here and a 3/4 here. That gives me 3/4 x plus 3/4 x is indeed 3 halves x. Now, a lot of students would prefer to work this out in decimal form, and you are free to do so. This would literally be 1.5 in decimal form. Now, you can think of that like $1.50 if you want. And when I take half of $1.50, I'd have 75 cents, or literally 3/4 in both locations. Alright, back to the problem as written here in fraction form. I know that my first terms give me my x squared. My outside and inside give me my middle term, which I was required to have. I now can determine what this last term needs to be in order to factor into this perfect square trinomial, this number or binomial times itself, in other words. 3/4 times 3/4 gives me the 9/16 here. But I can't just add it to the left side, I've got to add it to the right side. And of course it would still be here in the next step. Let's talk about the arithmetic here a little bit. I don't have a common denominator here on the right side. What I'll need to do is literally multiply top and bottom here by 8. Let's take a look at that now. On the left, I basically had x plus 3/4 times itself, or x plus 3/4 squared. On the right side, I multiplied top and bottom by 8. 5 times 8 would give me 40 over 16, plus 9 over 16 would give me the total I needed here of 49 over 16. So basically, what I have on the left side is x plus 3/4, the quantity squared. On the right side, I have 49/16. Once again, to get rid of the power, I take the square root of both sides. The square and the square root cancel, and that simply leaves me with x plus 3/4. On the right side, this time I can actually take the square root of both numbers. Now, first of all, I'd like you to notice that either a positive or a negative times itself would give me the 49/16. The square root of 49 is 7, the square root of 16 is 4, so my answer could either be positive 7/4 or negative 7/4. And again, what I want you to appreciate is that negative 7/4 squared would indeed be positive 49/16. My last step now, I simply need to subtract the 3/4 from both sides of the equation. On the left, that will cancel. And on the right, I basically have my answer, but I'm going to write it in a slightly different form. I have x on the left. On the right, I have 3/4, that should be negative 3/4, plus or minus radical 7 over 4. If I have negative 3/4 plus 7 over 4, that would leave me with positive 4 over 4, or 1. On the left side, if I have negative 3/4 minus 7 over 4, that would leave me with negative 10 over 4, or negative 5/2, or negative 2.5 if you prefer. Now, the one piece I left out is that this actually factored. I know that because the square root here worked out to an even number, or at least the top and bottom were even. It's truly a fractional number. I would like to leave it for you as an exercise to go back and factor this initial equation we had at the very beginning and see if you can solve it by factoring. As a final contrast, let's solve a problem by actually using the quadratic formula. I've got an equation here which again will not factor. I must use completing the square or the quadratic formula. To be honest, the quadratic formula is the much easier of the two. Given a choice, that's always what I'm going to do. In this case, a is always the coefficient of my squared term. So in this case, since there isn't a coefficient, a is understood to be 1. Remember, when you're multiplying and dividing and you've got nothing, you've got 1. B is the coefficient of my first power term, or my x term, and my constant is my c factor. Now let's take a look at the quadratic formula. Basically what I need to do is substitute all of these numbers into this formula. And then I need to only do the arithmetic. Truthfully, on the test you'll be able to just put those numbers into your calculator to come up with a solution. Notice this negative b. That literally means the opposite of the value here. The quick way to think of this, anytime you stick a negative in front of a number, it changes the signs. If that was a positive 6 and I stuck a negative in front of it, it would obviously be a negative 6. The same will work here. If I have a negative 6 and I stick a negative in front of it, I'm literally going to get a positive 6 because an even number of negatives cancels out and makes it a positive. At any rate, as I go through, let's look at the rest of it as well. The negative 6 I put in for the b, so I'll have negative 6 squared, minus 4 times my a value times my c value, all over the quantity 2 times a. Let's look at some of the arithmetic now. Again, this double negative literally just more or less cancels out and becomes a positive 6. Negative 6 squared, I have two negatives, or a negative times itself, results in a positive 36. The same is true of the product here on the right, the second term underneath my radical. I have two negatives here as well, so it will be positive. 4 times 1 times 8 is 32. 36 plus 32 is, of course, 68. So my answer, frankly, is positive 6 plus or minus the square root of 68 over 2. I will accept this on the test, but just as an exercise, let's reduce the radical and the fraction. First of all, if you reduce this radical, it actually becomes the square root of 2 times the square root of 2 times the square root of 17. Now the square root of 2 times the square root of 2 is simply 2. So this reduces to 2 radical 17. I can now rewrite my answer as positive 6 plus or minus 2 radical 17 over 2. Now I'd like you to notice that 2 goes into all of these terms. 2 goes into 2 once, 2 goes into 6 3 times, and 2 goes into 2 once. Of course, 1s are nothing, so I'm not going to have anything on the bottom at all. 1 times radical 17 is merely radical 17. So my final answer is literally positive 3 plus or minus radical 17.